So let's see if you can identify the three major types of bonds: ionic, covalent, or metallic. It's a little quiz. We'll also include within the covalent world some details: polar covalent, nonpolar covalent, things like that. And you should be aware, of course, that there is also a fourth major bond type. Each of these are, that's right, James bonds. Yeah, okay, screencast 7.3. Tell me, is it ionic, covalent, or metallic? Sodium chloride? Well, metal, non-metal. If you want to get these all right, be careful. Have a periodic table out and just go ahead and check it. If that first one's a metal and it's something different after that's like a non-metal, then there you go. It's a ionic bond. Check that one. You'll see fluorine's over to the right. It's non-metal. Iodine's not a metal either. That's covalent. Magnesium chloride. You might recognize right away magnesium is a metal. That's ionic. CO2. Carbon's not a metal, right? Check to be sure. Covalent. Sodium hydroxide. Is sodium a metal? If you take the time, scope it out, it's way over on the left. Oh yeah, ionic. Notice that we're specifically asking about the sodium to hydroxide bond. There's also an oxygen-hydrogen bond here, which we're not talking about at this point. Iron, just plain old iron. It must be a whole lattice of iron to iron to iron to iron. Therefore, nothing but metals. It's a metallic bond. Let's talk a little bit about the polarity of bonds and molecules. If it's the exact same thing, then these electrons that form this bond, and we'll later learn that it's two electrons forming this bond, are completely evenly shared. That means we say it's nonpolar. Is this going to work? There it is. Oh, a little bit from before. That's the little test method. Look for a metal. If you see one, it can't be covalent. It's going to be either ionic or metallic. 90% of the time, it's going to be ionic because it'll be followed by a nonmetal. Okay, carbon-carbon. Evenly shared, they say that's a nonpolar covalent bond. But this one, the electrons spend more of their time on which element? It must be the more electronegative element, the one closest to fluorine, which is definitely oxygen. So it's partially positive here, partially negative there. It's getting closer to ionic. This is that whole continuum thing I've been talking about. And so that would be called a polar covalent bond. Getting a little bit more salty, if you will. And here's an exception. Carbon-hydrogen bonds have very close electronegativities. They're shared pretty evenly. Plus, they're ubiquitous, and everybody knows that things like hexane and other hydrocarbons are really non-polar solvents. They don't dissolve much except other, like greasy solvents like that. So we're going to call a carbon-hydrogen bond a non-polar covalent bond. Screencast 7.3.